Okay, I want to prove that Temple OS is 100% open source. So we go to my web page, we go to downloads, download ultra small distro 2 meg. It's 2 meg. We're saving to my downloads directory. It's 2 meg. And we go into VMware, new virtual machine, typical. The ISO is ultra small distro 2 meg, other 64-bit. We call it ultra small. 8 gig disk, RAM 5 gig, processors 8 cores. Finish. So now we're installing onto the hard disk. So we say yes, we install on the hard disk. Yes, we are in VMware. And now it's copying 2 meg onto the C drive, and it's copying 2 meg onto the D drive. They're identical. During the day, I periodically back up from C to D, and then if it gets messed up, I boot the D drive and fix it. C is my master, and I just copy from my master to my backup. Reboot, yes. Okay, so now we're going to boot the C drive. Now the first thing to notice is we have the D drive and the C drive are identical. We're going to delete all the binaries and recompile to prove that it's 100% open source. So first thing I'm going to do is delete the format the D drive. Yes. So if I do, now I look on the C drive and the D drive. Okay, the second thing I'm going to do is find file *bin, find binaries. We go to the C drive. Okay, so there's kernel bin, compiler bin. This is the leftover from the CD-ROM kernel bin, and we have the bootloader and the old master boot record. So I go to Control D. Let's delete the kernel bin. Delete compiler bin. We delete kernel bin in the root. So now we do drive C find file /bin *. Okay, so I deleted the binaries. So at this point, 43,000 lines of code have been compiled. You might wonder what that is. Basically, half the kernel, half the operating system is compiled ahead of time, half is just in time, and there's 80,000 lines total. So the kernel and compiler are compiled ahead of time. Those were the 2 bins, and the other half is the Atom directory. So the reason it's showing 43,000 lines of code down here is because during boot it does the bootloader, then it loads a kernel bin, and kernel bin compiles start OS, and this compiles headers and then does the Atom directory. So anyway, we're going to make OS install boot. We're going to compile the kernel and the compiler modules, and we're going to install we're going to reinstall the bootloader. So let's just look to see what we're doing. It's going to compile the kernel project file, which also does a config. And we're going to compile the compiler project file, which includes the compiler code. So make OS install boot C. When we're booting, this is going to be the C drive by the time it boots. And on this disk, we have a C drive and a D drive. So the first is the C drive, and it's an ATA hard disk. We're going to probe. Now we could enter the ports, but there's a shortcut. We can enter these little single-digit numbers. One for the ATA is and we're not going to install any more drives, and we're going to use the default disk cache. We're going to use default options. Now look, it says 91,000. Now the reason it says 91,000 is it was 42,000, and then it compiled the compiler and kernel. Now if we do find file star bin, we have kernel bin and compiler bin. Now we can reboot, and it rebooted okay. So let's look around and see what we have. We have the Atom directory has the editor, the document editor. It has the graphics library. It has the file manager, which is this thing we're using right now. The documents do trees and stuff like that, as well as sprites. And we have the boot record. We have the master. This is the partition boot record. This is the master bootloader. It does the same thing, it serves the same purpose as grub, but it's much smaller. This file will make an ISO. So, and this is where it installs onto the partition. Anyway, so what did I mean by install onto the partition? So if we go to the root, do a directory star, and we do a full directory. So kernel.bin is installed onto cluster 4. So the boot block got patched with the address of that file so that it doesn't have to navigate the file system. Anyway, so the other thing I was going to show you is we can make an ISO file in your home directory when you install do distro. So what does this do distro do? It copies all the files and makes an ISO file. So leaves us. So it made an ISO file. I can show you how to get that out of VMware. Getting files in and out is tricky. Anyway, so let's just see. Do distro copied trees of copied directories, and then it called make ISO. It also called make OS. It also recompiled, and that's where that kernel bin in that boot directory comes from. The one we deleted. The kernel bin that's in here, that's when you do make ISO. So we made an ISO that's, now let's show how to, so I'm going to shut down, then I'm going to go into VMware file, mount virtual disk. So we want VMware Ultra VDMK volume FAT32. We want target mount. I have a directory VM disk, and you can. We want to read. If you want to read write, you click that. Otherwise, you do just read. And we have to tell it which of the two. I haven't done this in a while. And what did it say? Insufficient permission. Well, anyway, play around with this, and okay. Anyway, then you can get the file in and out. I have a script. I'll show you what I do for my I have VM mount for my TOS. So I unmount and then I change mod 777 and then I mount using that command, VMware mount, and then you tell it the which of the two that I always mount my D and not my C, because my C is my master and my D is my backup on my disk. And when you interact with Windows or Linux, it will corrupt the disk. So always do your D and then just recopy. It corrupts really quickly if you delete files or anyway. So that's how that works.